Let's re-emphasize some more points that we have seen before in other contexts and different words. For example, policy, legislation and institutional frameworks from this European Commission report on guidance for adaptation in water and climate change. Policy should create an enabling environment for adaptation to climate change through, among other things, climate proofing of policy and legal and institutional frameworks, and by strong communication. This is basically about mainstreaming adaptation, as we talked about before. Any policy should be based on understanding that stable and unchanging baseline conditions no longer exist. So we are already in a climate that's changing and will continue to change even if we magically stop emitting greenhouse gases completely. Climate change adaptation should be integrated into existing policy developments. This integration can also enhance coherence among policy sectors and avoid potential conflicts. Note that we are talking directly about climate change adaptation, but this is obviously also very relevant for other sectors like food, water, energy, health. Okay, spatial planning is an important basis on which to develop policies that take into account all sectors. So there we are, and NDCs have to be synergized with adaptation, mitigation, health, water, food, energy, etc. Policy development should be based on the principles of multi-level governance. Legislation should be developed in a flexible way and should not present barriers for adaptation. Transboundary agreements should include provisions for flow variability, so that if you have drought upstream or increased demand downstream, there is legal mechanisms to deal with these variabilities. The roles and responsibilities of institutions dealing with climate change adaptation should be clearly defined. Dedicated research teams should be established to improve understanding of the implications of climate change for water resources and their management. Joint bodies should have the mandate, capacity and means to ensure they can execute their responsibilities in developing and coordinating adaptation strategies for transboundary basins. Proper education, capacity building and communication are imperative for climate change adaptation, especially for water. So let's move forward to information and monitoring needs for adaptation strategies, design and implementation focused on water here. Adaptation to climate change requires a multi-stakeholder approach to identify data needs according to the principles of integrated water resource management. Data collection should cover all aspects of the hydrological cycle, considering the needs of the final users but not limited to it. Data collection should also cover explicit information on water uses, so that you have a portfolio of where the water is going and how adaptation has to worry about wastage, overuse, or dealing with shortages or too much water, too little water that we talked about. Information sharing between sectors, especially at the transboundary level, is essential to jointly assess vulnerability to climate change impacts. So hydropower requirements, irrigation requirements, industry, etc. Across boundaries, very critical to track. Historical monitoring stations should be maintained to have sufficient time series of data. Monitoring and observation systems should be ready to adapt to climate to changes in information needs that could occur in the future, and should consider interactions between the different variables. Information for disaster risk reduction, for example, considering environmental and social vulnerability assessments, is of crucial importance. Obvious points, and yet we need to go through them maybe more than once for sure. 4 elements of effective early warning systems and deriving information needs. Risk knowledge is critical. Monitoring and warning services, of course. Response capability and dissemination and communication. Under each quadrant there are some details. So questions for risk knowledge: are risk maps and data widely available? We talked early on about how information should be available for stakeholders, people and firms to make sure that they themselves are adapting properly and reducing their exposure to risk as well. Can accurate and timely warnings be generated? This is very critical for adaptive management, learning by doing and being resilient. Are people prepared and ready to act on warnings? So response capability or last mile gaps, training, communication, building national and community response capabilities are very critical. Dissemination and communication. Is the warning information clear and usable? Useful and usable are not always the same thing. Many websites put up information thinking they are useful, but unless they are used and considered usable, they will not be useful in reality. Okay. Examples of simplified meteorological, hydrological, morphological data and data on water quality needed for scenarios and vulnerability assessment. Just quickly running through. Meteorological data, we've seen these many times. Hydrological data, so water levels in river and discharge, ice phenomena, sea levels, groundwater levels, nationally generated water resources compared with transboundary water resources. And it's not so trivial, because getting water data, even if you want groundwater levels or soil moisture, it's a big, massive, monumental challenge in most places. Even though they are very critical for decision making on water resource management for food, water, energy, health. Okay. Morphological data, sediment concentrations and loads in rivers, areas of glaciation, coastal erosion, topography and land use. Water quality data, very well known already. Bacteriological, chemical, physical, coastal saline intrusions, bioindicators, water temperatures, and so on. Statistics related to these elements include homogeneity of data, mean annual, monthly, seasonal, or daily values. Spatial resolution is very important. Maximal, minimal, and selected percentiles and respective return periods. How they are changing in time can only be tracked if we have data for the return periods. Measures of variability such as the standard deviation, continuous records in the form, for example, of river flow hydrograph. Obviously, this is not a comprehensive list by any means. Summary of emergent pathogens. Viruses, I won't read all of these, but you can see the health significance is high for most of them, with gastroenteritis, hepatitis, respiratory and intestinal or influenza diseases. So these include norovirus, sapovirus, hepatitis A, rotavirus, enterovirus, adenovirus, avian flu. All these you have heard of. Bacteria, pathogenic E. coli, so Campylobacter, Helicobacter, Legionella, Vibrio, Cholerae, Paramyliticus, Vulnificus, Alginolyticus, Cyanobacteria, and so on. Again, diseases ranging from gastroenteritis to stomach and duodenal ulcer, pneumonia, cholera, wound infections like septicemia, otitis, lethal septicemia, and so on. Protozoa include Cryptosporidium, Glaridia, Naegleria, and Acanthoamoeba. Okay, so health significance again, and you have things like meningoencephalitis, keratitis, and blindness as well. River blindness is quite common. How far am I from finishing? I still have a few slides. So let's leave this podcast here and come back and look at scenarios and models for impact assessment and water resource management in the next podcast. We will likely wrap it up in the next podcast. This one is a bit short, but that's okay.